Good morning. Today we will study SR flip-flop experiment. Now for SR flip-flop experiment, you are requiring your flip-flop kit and a connecting wires. These are the connecting wires. Now before proceeding the experiment, I just gave the overview of your SR flip-flop. So as you have studied that SR flip-flop is simply a sequential circuit. Okay, so by sequential circuit we mean that in a circuit the present output depend on the present input as well as the past output. Okay, so that circuit is basically called as a sequential circuits. Now this is a block diagram of your SR flip-flop, and this is a logic diagram. Now here, so in this you have to be seen that this will be simply a SR latch, that is SR latch circuit, or you can say that SR flip-flop is just a modification of your SR latch. So here you are just using a clock in SR flip-flop. Okay, now I just make a truth table for your SR latch. So the inputs for the SR latch, that is represented by your S star and your R star. So first, if the input that will be your S star will be 0 and R star will be 0, at that time the output that will be your invalid. By invalid we mean that if you are giving input 0 0, your output will be 1 and 1. Okay, so this is not possible because this is Q and Q bar. If this will be 1, this must be 0, because both are complement of each other. Okay, so but the output will be your 1 and 1, so this will be your invalid state. Okay, so that cannot be used. The next will be your, when your S star will be your 0 and R star will be your 1, at that time your output will be your 1 and 0, and that state is called as a set state. And next will be your, when S star will be your 1 and R star will be 0, then your output will be your 0 and 1, and this is called your reset state. And when both will be your 1, this is called as a memory. By memory we mean that whatever the previous value that will be stored, it can be displayed. Okay, there will be no change. Now this is basically truth table for your SR latch. Now for your SR flip-flop, so this is a truth table of your SR flip-flop. So in SR flip-flop we are using a clock. So here we are using a clock. Now first, when the clock will be 0, at that time whatever the value of SRR, whatever the value of S or R, either it will be 0 or 1, doesn't matter. When this will be a deactivated, this means that this clock will be 0, so there will be no effect on the output at that time. This means whatever the value of S or R, by X we represent, this will be either 0 or 1. You can say that it is a don't care. Okay, either it will be 0 or 1. So the output will be your memory state. Okay, whatever the value stored in the memory, that can be displayed. This means that there will be no change. Now the next will be when this clock will be activated. Okay, this will be your 1. It is in an active mode. At that time, if S will be 0, R will be 0, I just write here, this will be 0, let this will be 0, and your R will be 0, and your clock, that will be your 1. At that time, so this will be 0 and this is 1. So the output for the NAND gate for 0 and 1, that will be your 1. And for 1 and 0, the output will be your 1. So this is simply a latch. So I just explain you the truth table for SR latch. So for 1 and 1, there will be always a memory. Okay, so whatever the value stored, that can be displayed. This means there will be always a memory. There will be no change. Okay, there will be no change. Okay, now next will be your, when your S will be 0 and R will be 1. At that time I just make it S will be 0, R will be 1. Add that and just make it 1. Just make it 1. Okay. Now this is 0 and 1. Your output will be 1. Okay. And for 1 and 1, the output will be your 0. Output will be your 0. So for 1 and 0, this will be your last circuit. For 1 and 0. For 1 and 0, the output will be your 0 and 1. Okay. Here for 0 and 1, output will be your 0 and 1. This state is called your reset state. Okay. So similarly for 1 and 0, it will be your 1 and 0, and this state is called as a set state. And for 1 and 1, the output, that will be your invalid. Again there will be a, if you are applying 1 and 1, output will be your Q and Q bar. Both are same. Either it will be 0, 0, or it will be your 1, 1. So this cannot be used, and this is not possible because both are complement to each other. Either Q will be 1 and Q bar will be 0, or your Q bar will be 0, or this will be 1. But in this case, both will be same. Either it will be 1, 1, or it will be your 0, 0, and this is not possible. That's why we call this state as an invalid, and it cannot be used. Okay. Now this is just the overview of your SR flip-flop. Now come to the experiment. Now this will be your SR flip-flop. Okay. This is basically the circuit diagram for the SR flip-flop, or you can say simply a logic diagram for SR flip-flops, and these are the logic inputs. These are called as the logic inputs. Okay. So now, and this will be that will be your clock. Okay. The clock will be given from this. This is called as a clock pulsar. Okay. And 2 more points, that will be your PR. This is called as preset, and this is called as a clear. Okay. So preset is basically, simply you can say that preset is a predefined value. Okay. So mostly it can be used in counter, and this is just to clear the previous values. Okay. Whatever the value that can be stored, you can be clear it. Okay. For that we are using this. Okay. Now start connecting wires. This will be your S. Okay. I just connect it. Now first, this will be your, this will be your S, then this will be your R. Okay. Then this will be your Q. Okay. Then this will be your Q bar. This will be your Q bar. Okay. Then this will be your clock. This will be your clock. Just click here, clock. This will be your output. This will be the clock. Okay. Then, okay, 1, 2, and 3. Then this will be the inputs. These are the inputs. This side. These are the logic inputs. I just connect. This will be your S, and this will be your R. Okay. From here you are giving the inputs, either 0, 0, 0, 1, 1, 0, and 1, 1. Okay. Then this side, this is called like your output indicators. Okay. From here the output will be displayed. Now this will be your Q, and this will be your Q bar. Okay. Now after that, just connect this to a power supply. Okay, I just connect the kit to a power supply, and then from here just on it. Just on it. Okay. Now the kit will be, just check the main button. Okay, this will be in on condition. Okay. Now start with your experiment. Okay. Initially I just, no, you have to verify this truth table. You have to verify this truth table. I just take this truth table here. Okay. Now you have to verify the truth table. Okay. Now the first condition, that when the clock will be 0, whatever the value of S and R, Okay, either it will be 0 or 1. The output always be your memory state. Okay, it will not be changed. Let us check. Clock will be 0. Okay, I am not giving any clock. Okay, at that time I just see the outputs. This will, I just make it okay like this. It will be visible to you. Okay, now let us see, when this will be your 0 and this is 0, the value that will be, this will be a 0. Okay, now I just change the value, make it 1, make it 1. Okay, it will not be changed. Okay, either you make it 0, 1, 1, 0, whatever, what value, this remain the same. So that you have studied here, whatever the value of S or R, the value that will, the output will be always the memory state, that will be stored value. So here it will be a stored, that will be a 0 at that time. Okay, now next time I make S0 and R0. I just make S0 and R0 and apply a clock pulse. I just apply a clock. Here clock. I just apply a clock. Okay. At that time, the output is again a memory. That is no change. So whatever the value stored, that can be displayed at that time. So again, this will be your 0. That means the previous value will be a 0. It will be shown 0 here. Okay. The next combination, that will be your 0 and 1. I just make, this is 0 and this is 1. This is 0 and this is 1. Okay. And you are giving a clock. I just gave a clock here. Okay. The output will be your again 0 and 1. So this will be your 0 and 1. Okay. Now the next combination will be your 1 and 0. Now I just make S equals to 1 and this equals to your 0. At that time again I will give a clock. I just give a clock. So you are giving the output will be your 1 and 0. Now this become your 1 and this become the 0. Okay. The next state, that will be your 1 and 1. So I just make both 1 and 1. Okay. Now again we are giving a clock pulse. I just give a clock pulse at that time. Okay. So you have seen that this will be your 1 and 1. So this state is called like your invalid state. Okay. Thank you.